Hello students, so let's start discussion of test 87. Overall paper easy side पर है. 3 questions are in difficult category, 10 questions are in medium difficult category and 32 questions are in easy category. So according to me 150 plus is a good score. So let's see first question. The binding energy per nucleon of deuteron is this and helium nucleus is this. If two deuterons nuclei react to form a single helium nucleus, then the energy released. So energy released is binding energy of products. Energy released is binding energy of products minus binding energy of reactants. Okay, so energy is binding energy of products minus binding energy of reactants. So binding energy of products, so 4 is the mass number and per nucleon this is 7 mega electron volt. Binding energy of reactants, 2 deuteron fuse, so 4 is the mass number and into 1.1, so this is 28 minus 4.4 MeV, so this is 23.6 mega electron volt. Okay, first question. Second question, the ratio of areas of the electron orbits for the first excited state and the ground state for the hydrogen atom. Okay, so area is proportional to r square and r is proportional to n square, so this is proportional to n to the power 4. So area of first excited state and the ground state, A2 upon A1 is 2 raised to power 4, that is 16:1. So B is the correct option. In gravity-free space, a man of mass m standing at height h above the floor throws a ball of mass small m straight down with speed u. Okay, so space is gravity-free. Okay, so center of mass of man plus ball system will remain fixed. All right, so this is the floor and this is height h. So initially center of mass of the man plus ball plus system is at height h. Okay, so now when the ball reaches the floor, the man will move upwards. Let's say capital H is the y coordinate of the man, so capital M into capital H plus small m into 0 upon capital M plus small m. This is y coordinate of center of mass which remains fixed at h from the floor. So capital H is small h capital M plus small m upon capital M, which is 1 plus small m by capital M. So 1 plus small m by capital M. So A is the correct option. A smooth steel ball strikes a fixed smooth steel plate at an angle theta with vertical. So the velocity component along the floor, velocity component along the surface will remain same and the velocity component along the normal will become E times. Okay, so let's say angle is theta. So angle is theta, this is the floor and the ball strikes at an angle theta. Okay, so just a minute, ball strikes at an angle theta. So let's divide the initial velocity in uy and ux. Okay, so this is the normal and say ball comes at an angle theta with speed u and rebounds with speed v at an angle alpha. All right, so vx is equal to ux and vy is e times uy in magnitude. So tan alpha is vx upon vy, which is ux upon euy. Ux upon uy is tan theta, so that is tan theta by e. So alpha is tan inverse tan theta by e. You can learn this as a formula as well. A particle of mass m oscillates along the horizontal diameter AB. Okay, so horizontal diameter AB, it oscillates along the horizontal diameter AB. That means it's moved from B to A and vice versa. At any instant, the kinetic energy of the particle is k, then the force applied by the particle on the shell at this instant is. So let's say particle is at an angle theta from vertical. So mg is acting downwards, normal reaction is acting in this direction, and this angle is theta. So net force towards center n is n minus mg cos theta is equal to mv square by r. So n is mg cos theta plus mv square by r. Okay, now kinetic energy of the ball, from B it moves down by r cos theta. Okay, it moves down by r cos theta. So mg r cos theta, this is loss in potential energy, which is equal to gain in kinetic energy, half m v square. Okay, so mg r cos theta is k, so this is k plus mv square, which is 2k upon r, so that is 3k by r. So C is the correct option. If a magnet is suspended at an angle of 30 degree to the magnetic meridian in a plane at an angle of 30 degree to the magnetic meridian, the dip of the needle makes an angle of 45 degree. Okay, so phi is the true dip. Phi is true dip. So a magnet is suspended at an angle of 30 degree to the magnetic meridian. The dip of the needle makes an angle of 45 degree with the horizontal. Okay, so BH dash in this plane is BH cos 30 degree, and BH cos 30 degree, which is B cos phi into cos 30 degree, and BV in this plane is BV sin phi. Okay, BV dash is BV, which is B sin phi. So BV dash upon BV BH dash, which is tan phi dash, is B sin phi upon, so this is tan phi upon cos 30 degree. So tan phi is cos 30 degree into tan phi dash. Phi dash is apparent dip, so this is root 3 by 2 into 1. So phi is tan inverse root 3 by 2. So according to me, the correct option should be A. The resistivity of potentiometer wire is this, area of cross section is this, current is this, the potential gradient. So potential gradient X is potential drop on the potentiometer wire upon length, which is I into resistance of potentiometer wire upon N. Resistance is rho L upon A upon L. So this is I rho by A. So now substitute the data, calculation is easy, you can solve it. An ionization chamber with parallel conducting plates as anode and cathode. So we are given number of electrons 5 into 10 to the power 7 centimeter cube per centimeter cube, number of electrons, and the same number of highly charged positive ions per centimeter cube. The electrons are moving with speed VE. If the current density is this, then the velocity of positive ions moving towards the cathode. Okay, so current is actually I equals NEAVD, so 5 into 10 to the power 7 per centimeter cube number of electrons. Okay, so say we electron density, this rho of electron, this is number of electrons per centimeter cube, number of electrons per centimeter cube, this is rho of electron, multiplied by electronic charge, this is number of total charge in per centimeter cube, into area into speed. This is amount of charge crossing a area per second. Okay, we know rho AV is the speed, rho AV, see, rho is number of electrons per centimeter cube multiplied by area, so number of electrons per centimeter multiplied by VE, so that is number of electrons in V length which crosses a given area in 1 second. So charge crossing a given area in 1 second is rho EAVE. And say electrons move from left to right, then the current will flow from right to left, and because of positive ions also current flow will from right to left. So plus rho positive ions into E into A into V of positive ions, this is electric current, upon A, this is current density. Okay, so J is rho E and rho I are same, so let's take it common. Rho and E is same, area cancel, this is VE plus VI. Okay, so VI is J upon rho E minus VE. So J is 4 into 10 to power minus 6. Rho is 5 into 10 to power 7 per centimeter cube. So 5 into 10 to power 13 per meter cube. So 5 into 10 to power 13 per meter cube into 1.6 into 10 to power minus 19. Okay, minus VE. So this is 10 to power 13, 10 to power 6, 10 to power minus 19. This cancel. 1.6 into 5, 0. This is 8, 4 upon 8, 0.5. So 0.5 minus 0.4. So this is 0.1 meter per second. So A is the correct option. Charge Q is divided into two parts such that their charges are in the ratio 2:3. The charges are kept at a distance of 1 meter in vacuum. The electric force between them. So we can use Q1 is 2 upon 2 plus 3 into 1 microcoulomb. So that is 2 by 5 microcoulomb. And similarly Q2 is 3 by 5 microcoulomb. Now we can calculate the force K Q1 Q2 upon R square. Okay, so we can calculate the force. Calculation is easy. Now next question. Two identical conducting balls A and B have positive charges Q1 and Q2 respectively. The balls are brought together so that they touch each other and then kept at their original positions. So guys, when the given charges, when the total charge is divided into equal halves, then the force between the particles is maximum. So initially Q1 was not equal to Q2, and when Q1 and Q2 are touched, the total charge divides into two halves. Okay, so the force will enhance, so greater than that before the balls touched. So B is the correct option. The primary windings has this, secondary has this. So NS upon NP, the primary has voltage this, and then the secondary. So VS upon VP, VS upon VP is IP upon IS is equal to NS upon NP. Calculation is easy, we can calculate it. Voltage of peak is this, the frequency of the source at which maximum power is dissipated. So maximum power is dissipated at resonance, and resonant frequency is 1 upon 2 pi root LC. 1 upon 2 pi root LC. So 1 upon 2 pi root LC. So 25 into 400. 25 into 400 milli and micro 10 to power minus 9. So this is 10 to power 5. So 10 to power 5 upon 2 pi under root, which is 50 root 10 upon pi. Guys, root 10 and pi are approximately same. So this is approximately 50 hertz. So D is the correct option. A planet of mass 4 times that of the Earth spins itself completely. So mass of the planet is 4 times. Mass of planet is 4 times, and one rotation is 96 hours. Okay, the radius of geostationary satellite. So geostationary satellite has time period equal to the time period of the planet. All right, so we know T square is 4 pi square upon gm into small r cube. So r is proportional to mt square raised to power 1 by 3. So the radius of about this planet compared to the radius of the stationary orbit around the Earth. Okay, so radius of stationary satellite about this planet. So Rp upon Re, mass is 4 times and time period is also 4 times raised to power 1 by 3. So this is 4. So Rp is 4 times Re. So A is the correct option. Two satellites are revolving around the Earth with speed v1 and v2. So we know v is G under root gm by r. So proportional to 1 upon root r. So since r1 is greater than r2, so v1 is lesser than v2. So C is the correct option. The total energy radiated is used to increase the temperature from this to this if absolute temperature is doubled. Okay, mind you, absolute temperature is doubled, then the increment in the temperature will be. Okay, so Q, which is sigma A T to the power 4, is equal to ms delta theta. So delta theta is proportional to T to the power 4. So delta theta 2 upon delta theta 1 is 2 raised to power 4, which is 16. So delta theta 2 is 16 into 0.5, which is 8 degrees Celsius. So theta final is theta initial, which is 20 degree plus 8 degree, so 28 degrees Celsius. So D is the correct option. If a Carnot engine is this, the efficiency is this, then the ratio of efficiency. So eta 1 is 1 minus Tc, which is 273 upon Th, which is 473, and upon E2, which is 1 minus Tc, which is 273 minus 200, so 73 upon Th, which is 273. So this is 273 upon 473. Guys, this ratio 273 upon 473, this is greater than 0.5 and lesser than 0.6. So the only option available is A, 0.577. Work done. So work done is area under the curve and v-axis, area under the PV diagram and v-axis from v1 to v2. So area is least in third, so work done is minimum in third. It's a straightforward question. A magnetic dipole is this, moment of inertia is this, performs oscillation magnet, the time period. So capital T, time taken will be n times capital T, which is n times 2 pi under root I by capital MB. So number of oscillations 20 into 2 pi, moment of inertia 12 into 10 to the power minus 6, and magnetic moment 6 into 10 to the power minus 2, and B is 2 into 10 to the power minus 2. So this is 12 into 10 to the power minus 4, 12 into 10 to the power minus 2, so 10 to the power minus 2, so by 10. So this is 40 pi upon 10, so that is 4 pi, so approximately 12 seconds. So A is the correct option. Wire loop of area A, resistance is placed in magnetic field, is withdrawn suddenly, the charge flown. So charge flown is minus of n times delta phi upon R. So that is minus of n times final flux 0, initial flux BA upon R, number of turns 1, magnetic field 2.4, area 20 centimeter square, so 20 into 10 to the power minus 4, and resistance, which is 10 ohm. So easily we can calculate. A coil of inductance this and resistance this is connected to this, a time lag between maximum voltage and current. Okay, so we need to first find the phase difference, time lag, phase difference between the current and voltage. So tan phi is XC minus XL upon R, which is 0 minus 1 by root 3 upon 1 by root 3, so minus 1 by root 3. So phi is minus pi by 6. Now if delta t is the time lag, then phi is omega delta t, and that is pi by 6. So delta t is pi by 6 upon 2 pi omega, which is 2 pi f. Okay, so this is 1 by 12, f is 50, so 1 by 600 seconds. So D is the correct option. An eagle flies at constant velocity horizontally across. So let's say velocity of eagle is VE, and from the eagle's perspective the mouse falls vertically with speed V1 from an observer on the ground. So velocity of mouse with respect to eagle is V1. Now what is the speed of the eagle, and from an observer on the ground perspective the mouse falls at an angle with speed V2. So velocity of mouse relative to ground is velocity of mouse relative to eagle plus velocity of eagle with respect to ground. So velocity of mouse with respect to eagle is V1 downward, let's say take j cap, and velocity of eagle with respect to ground is VE I cap. Now this is given V2 vector. Okay, so V1 square plus VE square is equal to V2 square. So VE is V2 square minus V1 square under root. So V2 square minus V1 square under root. D is the correct option. Then the velocity of the rod is, so this is a question from constrained motion. Okay, this C is moving with speed VC. So as B and C are connected together, so B will also move with speed VC. VB is equal to VC. Okay, now then the velocity of the rod is, So guys, when two rigid bodies are in contact, they move in contact, then the velocity along the common normal, they have same velocity along the common normal. Okay, so same velocity along the common normal. So va is, see, this is moving down, so b will move towards left, so a will move upwards. So velocity of a is upwards and velocity of b is in this direction, and both a and b will have same velocity along the common normal. Okay, so this is 37 degree, this is 37 degree, and this is 37 degree. Okay, so they have same velocity along the common normal. So va cos 37 is equal to vb sin 37. So va is vb tan 37. Now vb is same as vc, so this is 15 and tan 37 is 3 by 4, so 45 by 20. This is 20 into 3 by 4, so that is 15 meters per second. So velocity of a is 15 meter per second up, so 15 j cap meters per second. Okay, so this is question 22, 15 j cap meters per second. Now next move to question number 23. System is shown in figure. Assume that cylinder remains in contact with two wedges. The velocity of cylinder is. So again guys, this question is from constrained motion. Okay, the left wedge has velocity u towards left and right wedge has velocity 2u towards right, and we want to find out the velocity of cylinder. So let's assume we don't know the velocity or direction of velocity of cylinder because it will move horizontally as well as vertically. So let's assume that the cylinder has velocity ux horizontally and uy vertically, and we'll apply the constraint condition. Okay, so this is the left wedge incline. Okay, this is the cylinder. So let's say it has velocity ux in this direction and uy in this direction. Okay, so all right, so this is 30 degree and this is 60 degree. So ux and uy, and this is again 30 degree. All right, so for no slipping between left wedge, this is wedge 1 and this is wedge 2. So for no slipping between 1 and cylinder, their velocities along the common normal should be same. So velocity of wedge 1 along the common normal, this is u. So along the common normal, this is u cos 60. Okay, and this is 30 degree, this is 60 degree, and that of cylinder along the common normal is uy cos 30 minus ux cos 60 degree. Okay, and for no slipping for no slipping between 2 and c. See, 2 has velocity this is wedge 2 and wedge 2 has velocity towards right horizontally. So along the common normal, velocity should be same. Okay, so both 2u and ux, they have along the normal velocity 2u and ux. Okay, so this is the common surface is vertical surface, so common normal is along horizontal, so 2u should be equal to ux should be equal to 2u. So this is equation 2, This is equation 1. So ux is 2u. Now let's substitute ux in equation 1. So u cos 60, which is u by 2, is equal to uy cos 30, which is root 3 uy by 2 minus ux, which is 2u into cos 60, which is by 2. So this is root 3 uy by 2 is equal to 3 uy by 2. So uy is root 3u. So velocity of cylinder is ux square plus uy square under root speed. So that is 3u square plus 4u square under root. So that is root 7u. So speed of cylinder is root 7u. So D is the correct option. During beta emission, a neutron in the nucleus decays emitting an electron. So A is the correct option. A nuclear transformation. So Y goes to N alpha 3 Li7. So Y absorbs A X A Y Z plus 0 N1 is equal to 3 Li7 plus alpha 2He4. So from mass number conservation, A plus 1 is equal to 11. So A is 10. So correct option is B. The value of V for which the spring just attains its natural length. So initially there is extension in the spring, and that extension is mg by k. Now the block, both the blocks stick together and move with common velocity v dash, and finally both the blocks come to rest. So first, from momentum conservation, mv equals to 2mv dash. So v dash is v by 2. Now applying energy conservation, so delta ug plus delta us plus delta k is equal to 0. So delta ug 2m g x naught, this is gain in potential energy, delta ug, delta us finally 0 minus half k x naught square, which is mg, okay, half k x naught square. So half k x naught square, this is delta us plus delta k 0 minus half 2m into v dash square, which is v square by 4. All right. So 2mg x naught, which is mg by k, is equal to k by 2 x naught square, which is m square g square by k square plus mv square by 4. Okay. So 2m square g square by k. So m square g square, let's take common. So m square g square by k, 2 minus 1 by 2, which is 3 by 2, is equal to mv square by 4. So v is 6 m square g 6 mg square by k whole under root. So this is the correct option. K1, Ks and Kp. So Ks is k into 2k upon k plus 2k, which is 2k by 3, and Kp is k plus 2k. So Ks upon Kp is 2k by 3 upon 3k, that is 2 by 9. So C is the correct option. A plane electromagnetic wave of this intensity, this area, this, the wave to the momentum transferred by the wave to the mirror. So mirror, so it is perfectly reflecting, we'll assume. So momentum transferred is per second is 2u by c, which is twice of ia by c. So easy calculation, we can solve it. If the kinetic energy of free electron doubles, so lambda is h by p, which is equal to h by root 2 km, which is proportional to 1 upon root k. So kinetic energy is doubled, then lambda dash upon lambda is 1 by root 2. De Broglie wavelength becomes 1 by root 2 times. So C is the correct option. A frame made of metallic wire enclosing a surface area A covered with a soap film. If the area of the frame is reduced by 50%, the energy of the soap film. So energy of soap film is U is S into twice of A, so proportional to A. So delta U by U is delta A by A. So area reduces by 50%, then energy also reduces by 50%. So C is the correct option. In a turbulent flow, the velocity of liquid in contact with the walls of the tube. Guys, turbulent flow is beyond our syllabus. We need to just remember this Reynolds number, and up to 2300 Reynolds number, flow is laminar. Beyond 2300 to something number, flow is transient between laminar and turbulent, and beyond that, the flow is turbulent. But in turbulent flow, the velocity of the liquid in contact with the walls of the tube. So near the walls of the tube, a very thin layer of fluid has streamlined flow. So there the velocity is equal to critical velocity. Okay, but this is beyond our syllabus. You can leave this question, no worries. A person can see clearly object only when they lie between 50 and 400. So in order to increase a maximum distance of distinct vision, so maximum distance of distinct vision should be infinity, and presently it is at 400 centimeter. Okay, so the object at infinity, the lens should be such that the object at infinity, image of object located at infinity should form at 400 centimeter. So U is minus infinity and V is minus 4 meter. So 1 by V minus 1 upon U is equal to 1 upon F. So focal length is minus 4 meter. So power is minus 0.25 diopter. Minus means concave. So concave with 0.25 diopter. Concave mirror focal length produces an image P times the size of the object. So M is H2 by H1. M is H2 by H1 is equal to minus V by U is equal to minus F upon U minus F. So M is H2 by H1 is equal to minus U by U is equal to minus F upon U minus F. This is the expression. So M is P times real image. So this is minus P minus focal length is negative. So minus F upon U minus F. So this is minus PU plus minus PU minus PF minus PU minus PF is equal to F. So U is minus of F1 plus P upon P. So F1 plus P upon P. So D is the correct option. A disk of radius r and thickness r by c has moment of inertia I. The disk is melted and recast into a solid sphere mi about the diameter. So mass will remain same. So volume will remain same. So pi r square area into thickness. This is volume of solid disk, and say radius of the sphere is small r. Then this is equal to 4 by 3 pi small r cube. So small r cube is small r is capital R by 2. Now I dash I solid sphere is 2 by 5 m r square, which is r square by 4, and I of disk is m r square by 2 about its standard axis. So ISS upon ID is equal to 1 by 5. So I solid sphere is I by 5. So A is the correct option. A sphere and hollow cylinder rolls without slipping down two separate inclined planes and travel the same distance in same time. So they travel same distance in the same time. So time is T is under root 2s by A. So time is same, s is same, that means acceleration is same. The angle of plane down which the sphere rolls is 30 degree. So we know acceleration is g sine theta upon 1 plus k square by r square. So acceleration of sphere is same as acceleration of hollow cylinder. Acceleration of sphere is g sine 30 degree upon 1 plus 2 by 5, and acceleration of hollow cylinder is g sine theta upon 1 plus k square by r square. K square by r square is 1. So this is sine theta is 5 plus 2 7. So this is 10 by 7 into sine 30, which is half. So this is 5 by 7, which is roughly 0.7. So sine 45 degrees is 1 by root 2, which is 0.7. So theta is approximately pi by 4. So 45 degree is the correct option. In a common base transition, IC is the output current, I is the input current, the current gain alpha is. So alpha is IC upon IE. Alpha is IC upon IE, and which is slightly lesser than 1. So less than 1, B is the correct option. In a reverse bias diode, when the applied voltage is this, the current is found to change by this, the reverse bias resistance. So R is delta V upon delta I. So straightforward calculation we can calculate. 2 moles of oxygen is with 8 moles of helium. So CV equivalent is N1 CV1 plus N2 CV2 upon N1 plus N2. So 2 moles of oxygen and CV is 5R by 2. With 8 moles of helium, 8 into 3R by 2 upon 2 plus 8, which is 10. So we can easily calculate. A unit of area often used in measuring land is hectare. So hectare is defined as 10 to the power 4 meter per square. An open pit coal mines 75 hectares of land down to a depth of 26 meters in cubic kilometer. Okay. So volume in kilometer raised to power 3. Cubic kilometer is area in meter square, H in meter upon 10 to power 3 raised to power 3. Kilometer into kilometer, because we need to convert it into in kilometer cube. So area is 75 hectares. So 75 into 10 to power 4, and depth is 26 meter upon 10 to power 9. Okay. So 75 6 are 450, 0, 45, 72 5 2s are 150, 150 plus 45, 1950 into 10 to power minus 5. So this is 0.0195 kilometer cube. So this is 0.02 kilometer cube. So B is the correct option. In Young's double slit experiment is performed in water instead of air. So fringe width is lambda W is lambda d by d. Lambda will decrease, so fringe width will decrease. So A is the correct option. A parallel beam, how does the angular width? So angular width of principal maximum. So theta beta is twice of lambda by A. So increases when slit width is decreased. So C is the correct option. When the observer moves towards a stationary source with velocity v1, the apparent frequency is f1. So f1 is v plus v1 upon v into f, and f2 is v minus v1 upon v into f. So f1 upon f2, which is v plus v1 upon v minus v1, this is given 2. So 2v plus v1 is equal to 2v minus 2v1. So 3v1 is equal to v. So v by v1 is 3. So B is the correct option. Okay. A whistle producing sound waves of frequency this approaching a stationary person. The velocity of sound in air is this. A person can hear the maximum value of v. So frequency f dash is f v upon v minus vs. So f is 9500, v is 300 upon 300 minus vs, and this maximum is 10,000. Okay, so 0 0 10,000 cancel. So this is 285 is equal to 300 minus vs. So vs is 15 meters per second. So B is the correct option. A body moves this, the work done by the force. We can calculate W is Fx delta x for constant force, Fy delta y plus Fz delta z. So Fx is 4 and delta x is 3 minus 2, 1. And Fy, which is 1, delta y minus 4 minus minus 3, that is minus 1, plus Fz, which is 6, and delta z 5 minus minus 4, 9. So this is 6 9s are 54 plus 58 minus 1, 57 joule. So A is the correct option. In each heartbeat, a heart pumps V volume of blood at an average rate of P pressure. Assume 60 heartbeats per minute. This should have been minute per minute minute, the power output of the heart is, so 60 heartbeats per minute, that means 1 heartbeat per second. So power is dw by dt. Okay, so dw is pv upon work done per second is pv, and number of heartbeats per second is 1, so p into v. P is rho gh, so rho gh into v. Now rho is 100 mm of hg, so 100 into 13.6 into 10 to the power 3 g10 h 80 ml, so 80 into 10 to the power, h is 100 rho g h, and v, which is 80 ml, ml is 10 to the power minus 6. Okay, so 80 ml, so 80 into 10 to the power minus 6. Okay, so guys, 10 to the power 3, 10 to the power, so this is 10 to the power 3, 10 to the power 5, 10 to the power 6, 10 to the power minus 6, 80 into 13.6. So 80 into 13.6, just a minute. Rho is 100 mm of hg. So 100 into 10 to the power minus, just a minute. Let me substitute once again. 100 mm of hg. So this is 100 into 10 to the power minus 3. G, which is 10, H, which is 13.6 into 10 to the power 3, rho gh into volume, which is 80 into 10 to the power minus 6. So 10 to the power 3, 10 to the power 3, 10 to the power minus 6, this cancel. Okay, and 13.6 into 80, 13 into 80, 104. So 1040 into 10 to the power minus 3. So roughly 1.04 watt. So closest option is 1.06 watt. Okay, so that's all for today. Thank you.